Welcome. Today we'll solve a limit problem using a powerful technique, dividing by the highest power of n. Let's find the limit of north divided by the square root of n squared plus 1 as n approaches infinity. To solve this, we'll use a technique where we divide both the numerator and denominator by the highest power of n that appears in the expression. Looking at our expression, in the numerator we have n to the first power, and in the denominator under the square root, we have n squared plus 1. So the highest power of n is n squared. Let's divide both numerator and denominator by n squared. In the numerator, when we divide n by n squared, we get 1 over n. In the denominator, when we divide what's under the square root by n squared, we get the square root of 1 over n squared plus 1 over n squared. Now let's think about what happens as n approaches infinity. When n gets very large, 1 over n approaches 0 in the numerator. In the denominator, 1 over n squared also approaches 0, so we're left with the square root of 1 plus 0, which is just 1. Therefore, our limit equals 0 over 1, which is 0. This makes sense intuitively because the denominator grows faster than the numerator as n approaches infinity. Let's visualize this graphically. As n gets larger and larger, the function value gets closer and closer to 0.